Okay, so we got the simple power rule. We got our 6 trig derivatives. We got a lot of stuff, but not everything. I'm going to give you all the tools, at least most of the tools, right now. We're just going to call this section differentiation, or differentiation rules. Okay. We got 2 big ones next. Power, product rule, and quotient rule. Product rule? Product rule. Hey, okay. Product rule says if we take a derivative of f of x times g of x, then here is how we do it. We take the derivative of the first times the second function plus the first function times the derivative of the second. Okay? That is how it works. You can switch these around, you can switch these around, but because it's multiplication addition, just don't mix it up. I would prefer this one. Just do it that way. Quotient rule. Quotient rule is harder, but there's a song with it, I guess. So if you're taking a derivative of a function over another one, the derivative is g of x times f prime of x minus f of x times g prime of x. It's almost like this one, but with a minus. All over g of x squared. Now here's the sum. Low d high minus high d low. Low times the derivative of the top minus high times the derivative of the bottom. Low d high minus high d low. O square the bottom and away you go. Low d high minus high d low, square the bottom, away you go. And that's the sum. So that's quotient rule. And then chain rule. Most teachers just introduce this at the last moment, chain rule. I just want to get over it. Product rule, quotient rule, chain rule. There you go. So we're gonna get. These are all the rules. You're basically gonna get thrown at all these rules. So let's get started. Why don't we get started with all these rules? So my differentiation rules. There you go. Let's start with the product rule question. F of x equals sine x times cosine x. Typical question. Let's do it. Use product rule. The derivative of the first times the second plus the first times the derivative of the second. We can simplify this and we get cosine squared x minus sine squared x. That's your derivative. Let's use a quotient rule. Let's do it. Let's find f prime. Quotient rule, guys. So it's low times the derivative at the top minus the top times the derivative of the bottom. And then you square the bottom. Leave it like this. In the textbook, your answer will be simplified. But just leave it because that's your derivative. You got it. You'll be asked some problems where you do have to simplify this, but just leave it like that for now because you just found a derivative. That's it. You don't need anything else. So that's example. And that's example. Okay, easy enough, easy enough. These are very easy rules, you just have to memorize them. They're very obvious. Okay. Try this one. Find g prime of x. Using your rules. I'll give you a moment. Okay, so you can do this using quotient rule, or you can do this using product rule. I honestly want to use quotient rule because I don't want to deal with negative exponents. So it's low d high minus high d low square the bottom, and away you go. That's the song, right? These should be fast and easy. Okay. Next one. H of x equals secant x or x secant x. Let's do this. derivative of the first times the second plus the first times the derivative of the second. That is all. These are fast and easy, that's why I don't have to do them really fast. So, that's all I'm going to do for product equation. There's nothing else I should cover. Okay, let's do chain rule. Chain rule is the bigger one. It's the harder one. Here's what chain rule says. Let's do chain. I'm going to go through the process of chain rule, and then we're going to find a shortcut of chain rule, which is still chain rule, but we just find a pattern. Let's say f of x equals x plus 1 to the 9th power. If I want to find the derivative, I would have to expand that. But I don't want to. So what I could do is off to the side, I could do a substitution. And I'm going to make u equal x plus 1 because that's what I don't want to get out of it. So what we're going to get is this. So I'm going to let this y. And I'm going to say y equals u to the 9th because I substituted. Okay? Now dy du, hey, why did I say dy du? Because it's the derivative of y with respect to u. There's no x's in there. And this equals 9u to the 8th. Wait, that's this piece right here. That's dy du. We found dy du. It's right here. Wait, but dy dx is dy du times du dx. Wait. This is our u's and our x's. So the derivative of u with respect to x, the derivative of u with respect to x, equals 1. Wait. dy dx equals dy du times du dx. Oh, these cancel out. These du's and these x's cancel and we get dy dx. Wait. dy dx equals du dy du over times du dy. Wait. Let's resubstitute our u inside. Oh, we get that. Let's do another one and let's find out the pattern. Okay, let y equals the square root of x squared plus 10. Oh, we don't know how to differentiate this. It's a function inside another one. We have to use chain for this one. Let's let u equal x squared plus 10 and then we can do something. So now u equals the square root, sorry, y equals the square root of u, because we substituted u for x squared plus 10. Now dy du equals 1 over 2 root u. I just did it really fast. Let's do the 1/2. Do the 1/2. So if you were to differentiate, that would be 1/2. You're the negative 1/2, and that's how you simplify it. But I did this really fast. So, okay. That's that. Hey, we got one part of our channel. What about another one? We have to differentiate u with respect to x. That's 2x. Ooh, okay. Now let's multiply this. So dy dx equals, I'm going to put this on top of another. Anyways, it's dy du times du dx. Ooh. Let's resubstitute that. Do you see a pattern here? Between these ones. The pattern is, here's the pattern, and I'll make it even more easier. Okay. Notice how this portion is the derivative of this with, if you keep the inside the same. And then you multiply by the derivative of the inside. And that's where we get the chain rule from. That's the shortcut, and I'll write the shortcut over here. The shortcut is this. F of g of x, right? The composition. The derivative of this composition equals f prime of g of x times g prime of x. Ooh. That is the result of the chain rule. That is the result of the chain rule. So instead of constantly doing U's and stuff, we can just straight up know the pattern and get the answer right away. So if f of x equals x to the third minus 3x squared to the 100th power, wait, I can recognize this as this function is inside of this function, x to the 200th power. This is a composition of functions. G of x is x to the third minus 3x squared. F of x is x to the 100th. We can recognize this as a composition, and we know the chain rule would give us this. So the derivative of x to the 100th power is 100. Wait, we have to keep g of x inside of that. Okay, if we keep g of x inside of that, then we take the derivative of f. Ooh, wait, times the derivative of the inside. 3x squared minus 6x. That is the derivative. That is f prime. There you go. That's chain rule. Okay. Let's do some trig derivatives with this. Let's give another example. Let's say our function g of x let's say our function h of x equals the tangent of x to the third plus 3x squared. Wait, that's a composition. Tangent is our f. This inside is g of x. Wait, that's just the chain rule. H prime of x is the derivative of tangent, keeping this inside. Secant squared x is the derivative of tangent times the derivative of the inside. That's the inside that we're taking the derivative of. Okay? Easy peasy. Let's do another one. This one's a little bit weird. The secant of cosine of x. Composition. G of x is cosine, f is secant. So p prime of x is, well, what's the derivative of secant? What's secant x tangent x? Wait, but we keep the inside the same. We just keep it inside. Keep the inside the same. Just leave it there. And then you multiply by the derivative of the inside. The inside is cosine, the derivative of cosine is negative sine. I'm going to put the negative up here, put the sine up here. Yeah. The negative sine, there you go. You should be good with chain rule pretty much. I'm going to do some hard differentiation right now. Do some hard examples. Okay. Let's do some hard examples. We got time. Okay. There you go. Hard example. That doesn't look nice. In fact, I don't like that. But what is the most outer of them all? Like, what do I see that is outside all of this? A fraction. I see a big fraction going through the outside. I don't see an exponent, I just see a fraction. We gotta do some quotient rule. Okay, let's do quotient rule. Okay. So it's low times the derivative of the inside minus I times the derivative of the inside and then you square the bottom. And I'm kind of simplifying this. There you go. Okay. Let's take this one step at a time. Let's evaluate these derivatives. Okay. I'm going to do them on the side. What would be the derivative of sine squared tangent cosecant x? What is the derivative? Well, I have sine to the second power. Chain rule, chain rule, chain rule. So it's going to be 2 sine of the inside. All of this is the inside. Times the inside, which is the sine of this. Sine of something is the cosine of something. We keep the inside the same, multiplied by the inside, which is the tangent. Well, the derivative tangent of something is the secant squared of that something, times the derivative of that inside, which is the cosecant. What's the derivative of cosecant? It is the negative cosecant cotangent. Okay. What about the derivative of x squared times the cosine of x squared? Well, that's a product rule. That's the overall product. So this is the derivative of the first times the second plus the second. The first times the, it's negative sine. Keep the inside the same because it's chain rule. Times the derivative of the inside. We can simplify this a little bit more. Okay. So f prime of x is equal to what? Well, it's equal to x squared times the cosine of x squared times the derivative of this thing, which is that negative 2 sine of tangent of cosecant x times the cosine of the tangent of the cosecant x times the secant squared of the cosecant x times the cosecant x cotangent x time minus sine squared tangent of the cosecant x times 2x cosine x minus we got this point down, it doesn't matter. Minus 2x to the third sine x squared all over x to the fourth cosine squared x squared. Yikey, boys. That's what I'd call a hard problem. It's just using all our rules. It's all the rules.